Okay guys, so let's continue on seeing the n factor. Okay, so in this lecture we'll be seeing the n factor of compounds, then we'll be moving on the discussion of equivalent weights. Okay, n factor of compounds. So this is calculated via total cationic or anionic charge on the compound, or cationic charge on the compound. Okay, so for example we talk about NaCl, KNO3, HCl. The n factor for these compounds would be 1. Then we talk about K2SO4, H2SO4, ZnCl2. N factor for this compound would be 2. If we talk about AlCl3, FeOH whole thrice, N factor for this compound would be 3. Then Ca3PO4 whole twice, N factor for this compound would be 6. Okay, next let us talk about the equivalent weight, a new concept which is called equivalent weight. So equivalent weight is the weight of a substance combined or formed with 1 gram of hydrogen, 8 gram of oxygen and 35.5 gram of chlorine. So let's say we have an example of NaCl in which 23 grams of Na combines with 35.5 gram of chlorine. So the equivalent weight of Na would be 23 grams. If we talk about AlCl3, then 27 grams of aluminium combines with 3 into 35.5 grams of chlorine. Hence 35.5 grams of chlorine actually combined with 9 grams of 27 by 3 or 9 grams of aluminium. Okay, hence the equivalent weight of aluminium here would be 9 grams. Okay, if we talk about Na2O, then in example of this AlCl3, if it's not clear. Okay, so for Na2O, 23 into 2 grams of Na combines with 16 grams of oxygen. Okay, so equivalent weight of, so rather we have to consider what 8 grams of oxygen to calculate the equivalent weight. So 23 grams of sodium combines with 8 grams of oxygen, hence equivalent weight of Na in Na2O would be 23 grams. So just a note here before seeing more examples, that what is the equivalent weight? Equivalent weight is weight of substance which combines with 1 gram of hydrogen, 8 grams of oxygen and 35.5 grams of chlorine. Okay, so this is how equivalent weight of any substance is calculated in the compound in which it forms or combines with these grams of the following atoms. Next, if we talk about MgO, then MgO again 24 grams of magnesium combined with 16 gram of oxygen, and we have to take 8 grams, so divided by 2 on both the sides. This implies 12 gram of Mg combined with 8 grams of oxygen. Hence, equivalent weight of magnesium in MgO would be 12 grams. Next, let's talk about MgH2, magnesium hydride. So again 24 grams of magnesium in magnesium hydride combined with 2 grams of oxygen or hydrogen, and then this implies that 12 gram of magnesium combined with 1 gram of hydrogen. Hence the equivalent weight of Mg would be 12, because we compare any other compound with 1 gram of hydrogen which is getting combined with it. Okay, so next let us talk about what is a oxidant or oxidizing agent. Oxidant or oxidizing agent. So this is nothing but a substance which is used to oxidize other substances and reduce itself. Okay, next is, so another point in oxidant, that oxidant actually gains electron during the course of reaction. Next is reduction of oxidant takes place. Okay, next is what is a reductant. Let's see also what is a reductant. Or a reducing agent. A reductant or a reducing agent is some substance which is used to reduce other reactants. And reductants actually release electron in redox. Next point would be oxidation of reductant takes place. Okay, next let us talk about N factor. So N factor of oxidant or reductant we are talking about. Okay, so number of moles of electrons gained or released by 1 mole of oxidant or reductant is the N factor of itself. So number of moles of electrons gained or released by 1 mole of oxidant oblique reductant would be its N factor. Okay, next let's see some examples. So we have H2, which gives 2H plus 2 electrons. Okay, so N factor here would be 2. Okay, and equivalent weight of H2 would be moles of H2 upon 2. Okay, so not molar mass, not moles, it's a molar mass upon 2, so it would be 2 upon 2, which is 1. So in some minutes back we talked about equivalent weight. So that was in terms of H2Cl, HCl and oxygen atom, but that is also one of the method to calculate equivalent weight or equivalent mass of several uh, uh, atoms attached to those three atoms in a compound. But you can always use this formula that equivalent weight or mass can be calculated with molar mass upon n factor. Okay, this will also yield the same result whenever you are calculating equivalent mass. Yes, the calculation of equivalent weight is another method is there, which we discussed a few minutes back with respect to three atoms that were hydrogen, oxygen and chlorine, but this is a more generic method. Okay, next example is we have 2H plus 2 electrons having H2 gas. So n factor here would be number of, rather molar mass. So n factor here would be just be 1. Okay, so molar mass divided by number of electrons gained, that would be only 1, so n factor would be 1. Okay, or you can also have this, like you can also combine the weight of 2 moles of hydrogen, so molar mass would be 2, number of moles of electron gained by 2 moles of H plus would be again 2, so that would be 1. Okay, so with this we'll end this lecture. In the next lecture we'll be continuing on seeing more examples on the same.